back. We're going to carry on to the second part of this video, and we're still talking about section 6.1 in your book. So, where are the various broad categories of elements found? So we divide the periodic table into 3 groups: metals, nonmetals, and metalloids. And what are these elements? So you'll see in yellow all of our metals. These would be things that you traditionally think of as metal, like silver, copper, gold, aluminum. It also has some that you probably don't recognize as metals, and that would be things like sodium, lithium, calcium. These are metals, and they are the major portion of the periodic table. The nonmetals are the things like carbon, and you'll see them on your periodic table here in blue. And they include our noble gases and things like chlorine, fluorine, bromine. And they also include hydrogen. And hydrogen sometimes can act as a metal and sometimes as a nonmetal, so it's kind of a weird piece of the periodic table. As are the metalloids, and you'll see the metalloids here in that pale green. And these are the ones that touch that stair step. And these are some things that have both metal and non-metal characteristics. And they help us with things like semiconductors and making certain substances. So, most periodic tables are laid out like the one you saw. You'll notice that some elements from periods 6 and 7 are placed beneath the periodic table, and that's just to make it more compact to fit on a traditional 8.5 by 11 sheet of paper. So, each column or group in this table has 3 labels. That's because we can't all decide on how to label the columns. In the US, we use those shown in red. In Europe, they use the ones in blue. So I'm going to go back to that slide and show you. So we use the ones that are 1A, 2A, 3A, 4A, etc. International scientists typically do just 1A, 2A, and then they have 3, 4, 5, etc. So the IUPAC is the International Union of Pure and Applied Chemistry. It's an organization that sets standards for chemistry. In 1985, they proposed a new system for the labeling of the periodic table, and they numbered the groups from left to right in black, 1 through 18, which makes a lot of sense. Dividing the elements into groups is not the only way to classify them based on their properties. Elements can be grouped into 3 broad categories, and we've already mentioned those 3 names. Yes, you're going to have to know them, and it's based on their general properties. So, the 3 classes of elements are metals, nonmetals, and metalloids. And across a period, the properties become less metallic and more non-metallic. 80% of the periodic table are metals. And you can see that because it's a large majority of the squares on the periodic table. So what are the properties of metals? Metals are good conductors of heat and electric current. We use copper as a conductor in our wiring in our home. Silver is better, but it's way more expensive, so we use copper. And the copper cables must be 99.99% pure to be used in your home. When you freshly sand off the outer layer or cut the surface of metal, it will have a high luster. It'll be shiny. And this sheen is caused by the metal's ability to reflect light. All metals are room temperature, Our solids at room temperature, with the exception of mercury, is the only liquid metal at room temperature. Gallium melts just above room temperature. It'll melt in the palm of your hand. Metals are ductile, meaning that they can be drawn into a wire. They are also malleable, which means they can be hammered into sheets without breaking. So we can make aluminum foil out of metal. Blue is used to denote the nonmetals, and we are going to learn about the general properties of nonmetals next. Nonmetals have a greater variation in their physical properties than we have in the metals. Nonmetals can be gases. They can be, and so most nonmetals are gases at room temperature. Things like nitrogen, oxygen. A few are solids, such as sulfur and phosphorus. And bromine is the only liquid at room temperature. So there's only 2 liquids on the periodic table at room temperature. One is mercury, which is a metal, and bromine, which is a non-metal. Nonmetals also have a lot of variety in how they are put together. We can have diamond, which is a network solid. It is very hard. Or we can have something like phosphorus, which is brittle solid. But neither are malleable at all. Nonmetals tend to have properties that are the opposite of metals. So in general, metals are poor conductors of heat and electric current. Carbon in the form of graphite is an exception to this rule. Solid nonmetals tend to be brittle, meaning they will shatter when hit with a hammer. There is a stair step that separates the metals from the nonmetals, and those are shaded in green. And these are called our metalloids. A metalloid generally has a property similar to those of metals and of nonmetals. Under some conditions, metalloids may behave like metals, and under other conditions, they may behave like nonmetals. And controlling their behavior is based on changing the conditions. Metalloids, like most nonmetals, pure silicon is a poor conductor of electric current. However, if a small amount of boron is mixed with silicon, the mixture is a good conductor of electric current. And so the silicon can be used in the compound silicon dioxide, which is what glass is made of, or silicon can be cut into wafers and used to make computer chips. All of the known elements are listed in the periodic table. What are different ways you could classify the periodic table, the elements on the periodic table? Well, you can classify them by their atomic weight, which we no longer do, by their chemical properties, by their physical properties, or by their electron configuration. Is there more than one variety of properties among metals and nonmetals? Properties of metals are more constant, and there's more variety among the nonmetals. So, key concepts. Early chemists used the properties of elements to sort them into groups. Mendeleev is the father of the modern periodic table. He arranged the elements in order of increasing atomic mass. In the modern periodic table, elements are arranged in order of atomic number, mostly due to Moseley. And 3 classes of elements are nonmetals, metals, and metalloids. Glossary terms: periodic law and metal, nonmetal and metalloid. Big idea is that electrons and the structure of the atom, periodic tables may contain each element's name, symbol, atomic number, and atomic mass. And that's what I give you on your periodic tables. And there we are. Thanks for listening. I'll see you in class.